So this video is about the sensors, and this class is basically meant for the purpose of modeling the real world sensors in an IoT based network or fog based network, and it is actually being extended from the SIM entity class. We have already discussed about this class in our previous section, and this is something which allows a particular class, or I would say it allows that particular class to become an active component within the simulation when it is in runtime, right? So it can process a lot of different kind of events corresponding to it. So this class is actually present under the particular package, that is org.fog.entities, and if I show you it in the project folder, so it is over here inside this particular entity namespace, and I'm actually inside the Harshit's improved branch. So if you are not aware, you can check in the first section that I've given an explanation that there are two different branches which are there for this particular iFogsim, and I'm actually right now discussing within the branch which has been published by Harshit Gupta under the name of improve, right? So that is what we have. The overall, if we look at this particular section after the class has been declared, you can see there are 17 different private variables, where one is a static variable, and that is actually defining the tag for this particular log, right? So because we are supposed to do a debugging for the log based thing, because whenever the simulation is happening, some sort of automated messages are being displayed on the console, so that for that particular purpose it has been used. Apart from this, other 16 variables or parameters are basically defining various kind of different components to which this particular sensor is going to get supported. Now very first is gateway device ID to which the sensor is going to connect. If we are trying to use a geolocation, then in that particular part this particular parameter is going to work out. What is the output size? This is corresponding to how much transmission is going to be done. Then app ID, for which particular app ID the sensor is going to get connected. User ID, for which fog broker it is going to connect it to. Then tuple type, what sort of tuple it is going to transmit. Sensor name, it's basically the name given to this particular sensor whenever a particular topology is being defined inside the iFogsim based simulation. Then destination module to which it is going to report. Then at what transmission distribution is, at what particular set of time intervals it is going to transmit. Then controller ID, who is going to manage this particular set of communication for module based interactions. Then latency, how much latency will be there in the transmission. And then characteristics, this is corresponding to the characteristics of the particular sensor. So that's a different class which is over here. And then comes out is the application, to which application the sensor is going to get connected to, because application is basically divided into modules, and then app edges, and then all those stuff are been there. We have already discussed about it. Then destination module address, similarly the end devices and the IDs for this particular end devices. So this is what are there in terms of all the different kind of parameters, or you can say some markers which the sensor is going to get working with. Then if we talk about, because this is a class, Java based class, so there are 4 different constructors which are being provided. Now we know the constructors are being used for generating the instances of the particular class. So within the iFogsim simulation, whenever the sensor is going to get initiated, at that point of time, any one of these 4 constructor is going to get called to initialize the object. So if we look at how many set of constructors we have 4 different constructors, and each constructor have its different parameter values. So if we start with the shortest one, so we are providing the name, we are providing the tuple type as a parameter list, user ID, that means fog broker ID, app ID, that means application ID that is being generated from the scenario, and the transmission distribution. So these are the minimal that is going to be called for this particular set of sensor instance creation, right? So we know that this class has been extended by the sim entity, so that means the super constructor will definitely get called. So it is already there in all the constructors. So this is the first, this is the second constructor, third constructor call, and the fourth. So all the constructors are going to give call to the super class. So if we go and get inside the super class, we can see it is going to set up the name, and it is going to add an entity to the cloud sim. So that means the base a simulation engine is CloudSim here again, and the entity has been added to that. So overall, that is the purpose for calling this particular super constructor. So all the other thing, set app IDs, transmission distribution, tuple type, sensor name, user ID, destination module, and the set end device. So they all are being what they all are being methods which are going to populate the values of these particular set of parameters. So let me take you to the another set of sensor based constructors. So this is the second one where we are passing on the along with the distribution, we are also passing on the application instance, right? So they are all are being populated, and the app edge is something which is going to be utilized over here. So it is going to look for that how many app edges are there corresponding to that particular application, and then some sort of CPU length and network length is also being set correspondingly, and the set characteristics are being utilized here. Now set characteristics are is a method which is going to be used to create a new instance for this particular class, that is sensor characteristics, and you can see inside this particular part that what are the different set of parameters which are going to be passed. The additional ones which are going into that is the CPU length, CPU network length, and last one is the null. So we can see what are the different parameters which are there for the sensor characteristics. So we have ID, app ID, tuple type, then distribution, transmission distribution, CPU length, network length, and the geolocation. So geolocation which is going to be here is null right now. Similarly, the destination address is null, and the set end device ID is also null. What about the other constructor? So this is here. So here we are going to have the name, the user ID, the app ID, the gateway ID. So that means any of the fog device which is going to be over just over the above in the hierarchy of this particular sensor, then latency, then location, then transmission distribution, tuple type, and application. So with each set of added parameter, we are getting the flexibility of setting up of different kind of parameters by the user itself, right? So this is what we can understand from this. And finally, if we go to the maximum parameters, that is the 12 parameters. So we have actually 5, 6, 9, and now this is 12. So we can set all the different set of parameters which are over here, right? So that is being first done by the super method, and then they are going to be calling the different set of set methods, and it is going to work out correspondingly to set up the parameter values, right? So this is what is the purpose of this particular constructor set of functions. Now apart from this, now we know there are set methods and there are get methods. So if we look at because this is an entity, so if we look at the particular list, we have somewhere around 15 get methods, and in the similar way we have around 15 set methods, right? So they all are supposed to either setting up the values of these set of parameters or reading the values of these set of parameters whenever we are trying to utilize the sensor instance to read these values, right? Because these are private variables, we cannot access them directly with the instances. Whereas if you look at any of the get method or any of the set method, you can actually see they are public instances, and they can allow you to have the values either set to that particular parameter, or because by using the set method, or by within the get method you can actually get the value of that particular parameter out of this particular class. So that is the beauty of using the set and get method, and they are basically, this is basically a software design that is being done corresponding to a particular class. Now what about the next? Apart from all these 30 methods, there are certain methods which you are actually going to look at very carefully. So one is the process event method. So this process event method is one of the most important method. You can see that there are 4 different set of events that are going to be handled by this particular process event. So if you have gone through the previous section where we have actually talked about the core classes of cloud simulation engine, right? So we have actually defined the discrete event management, that how it has been done during the simulation part. So that this particular process event is going to follow that particular part. So here you can see there are different kind of tags which are being put. One tag is from the cloud sim tags class, that is resource underscore characteristics, and we know that the resource underscore characteristics is basically used to get the characteristics of the different resources which are available there in the data center if you are talking about the cloud sim. Whereas if it is iFogsim, so that definitely it is going to look for the characteristics which are there for the fog devices which are going to be there in the hierarchy list. Apart from this, there is a tuple acknowledgement, there is a emit underscore tuple, and there is basically endpoint connection. So fog events is a class which is going to be defining all these set of things. So I will be discussing about this particular class in a separate video, but still just I wanted to show you that what exactly it is. So here the tuple acknowledgement doesn't contain any of the methods, so that means right now this is dormant kind of thing. It is not going to do any specific part, whereas the emit tuple is going to do a transmission of the tuple, right? So we know that tuple is basically kind of workload which is going to be there, right? So workload which is going to be generated for this particular simulation part, and this workload goes from the sensor to the fog device, where the broker is going to go through the all requirements, and then it is going to be allocated to the application for further processing part. So this is what is there for this particular part. So overall, if we look at the process event, so because this sensor is an entity, so that means during the iFog simulation is happening, the sensor can send the event request to the other respective entities, or it can process the event request sent by the other entities. So that is the primary purpose of this particular function or method. If you are following the nomenclature of Java, so we can call it method. So that is what it can do. So 4 different events which can be handled through this particular process event method, right? So now, so if we look inside these set of cases, we can see there are certain calls which are been happening to different methods. So there is a method that is the process sensor connection, right? So if I look at this last case, I'm starting from the last case itself. So if I look at the last case, what is endpoint underscore connection? So it contains a process sensor connection which is going to take a parameter of the ADDR. So ADDR basically is a type of app module address, so which is going to be get from the EV, that is the event which has been generated, and then that data is going to be get from that. So this instance is going to be passed by other set of entity which is going to be coming to this particular sensor, and things are going to work. So what exactly this method does, it actually sets the destination module address to which this tuple is going to work around. So if we wanted to go and drill deep down into this, so we can actually see where this particular endpoint is going to get used. So I can go for open call hierarchy, and you can actually see the deployments which are been happening, and this is the process event which is inside the so here is the event which is going to happen. So endpoint has been identified, and that endpoint is going to have this particular tag with the corresponding of this particular set of data, because send now is basically having a particular entity name, right? And then the CloudSim tag, and then the object data. So this is the second signature which is being used for this particular send now. So from here it is going to initiate it. The broker is going to initiate this particular part, and it will take to the sensor, and then it is going to get executed correspondingly. So this is how the event has been initiated. If you have actually gone through the future queue and deferred queue section and the CloudSim section of the CloudSim prerequisite chapter, then you should be understanding this, that what the send now is and what send method is, and how this particular event is going to come to this particular sensor and work it around. So this is the very first section we have. Then let's move to this third case where we have emit underscore tuple. So emit underscore tuple is basically going to call the transmit method, right? So if we go inside this particular transmit method, you can actually see that it is going to look for that where is the destination address, right? So that means the process event is actually going to call, let me take you to the process event first. So the process event is actually going to call this particular event before the emit underscore tuple can be called off, right? So this is what is the beauty of this particular process event method. So first it is going to work around, and then because we need to have a destination address for a particular tuple, so if it is not there, it is going to return immediately, right? So that means the tuple is not going to transmit to any of the other entity or other module, right? So if it is not the case, then that means what we are going to look at is all the app edges that are there in the application, right? So that application which is going to be there for the set of the destination which has been set while the previous endpoint setup, right? So once we have that particular part, we are going to fetch the CPU length, and we are going to fetch the network length, right? So that once that has been done, that correspondingly we are now ready to generate the tuple. So if we look at the tuple instance, the app ID is going to be provided, the generate tuple ID is going to be there. So that is done by using this fog util class. So let's go inside this particular part. So you can see that whatever the previous tuple is, because we are going to start it with the 1, whatever the previous tuple is, that is going to get initialized, then added, and then being provided back to this particular part, so that during the whole course of the simulation we should be able to have the unique number for each tuple that is being generated. Now because this is a sensor, and sensor is going to send the request to the level above it. So that means the tuple up is going to be used for as a direction. So if we look at the tuple parameters, so first is the app id, second is the cloudlet id, right, or the tuple id that we have, and then we have direction, then we have the length, whatever the cpu length we are going to have, then pes number, how many processing elements are required to execute it, then what will be the file size for this particular tuple, so that the network bandwidth can be taken care of, and then we have the set of utilization models and all that stuff. So we know the utilization model full is going to be utilized corresponding to it. So that is what we have for the tuple itself, right? Then because it is supposed to be sent to some broker, so that is why we have the set user id, and we are going to get the user id, and this is going to bring us the value for the fog broker, right? So this user id is going to be set correspondingly. So let me take you back to the transmission again. So once we have all these things set up, then the tuple type is going to be set here. So tuple type is basically the sensor based tuple. That is what we have. Now tuple is going to be sent to some destination. So that is what we have, because edges can be edges define that from which node to which second node you are connected. So that is what we get. So this is a directed edge. So we are going to have a destination for that particular edge. Then we have a source module, whatever the name of the sensor we have, that is what we get. And then because we need to print that particular thing corresponding to the tuple, that the tuple is going to be sent by the sensor. So this is being done, and we are going to send this particular thing to the console log, and then correspondingly the actual tuple id is going to be generated by update timings. Now if we go inside this update timing, we can see it is going to use a timekeeper, right? So this is the unique id that is being generated corresponding to that particular section, right? So timekeeper's purpose is that we are going to discuss this thing in detail whenever we have its own video, but just for the timing, timekeeper is used for that, and it is going to maintain the time correspondingly, right? So let me take you back to the transmit again, and then comes out is that we are going to get the device to which this particular tuple is going to be sent. The tuple object is going to be passed to that, then the destination address with the fog id, fog device id is going to be sent, and whatever the VM id corresponding to that particular part, that is going to be used for it. So this is what is the purpose of the transmit method that is going to be called at this particular part. So let me take you back to the process event again, so we can see the transmit method, what exactly it is doing. It is creating the tuple, and that tuple is going to be passed on to a particular device, and then what we are doing is we are sending an event to the simulation so that the next tuple can be initiated or generated after a particular period of time, right? So we are going to get a transmission distribution. So we know the sensor are going to sense the data and send it to the device above it, right? So that may be a gateway device. So the get id is basically for the sensor, the distribution among the time that we are going to use. So maybe after a couple of seconds, after a couple of time units, it is going to generate this particular event, and again this particular section is going to be called, and the transmit method will create another tuple and will send it to the level above it. So this is what we have corresponding to a iterative kind of tuple generation, right? So it will do it anyway. Now then there is another method that is send tuple, right? So if we look at the send tuple, oh my god, I opened another one, so I need to go to send tuple here. This is a protected method, right? So that means if you are going to extend the functionality of the sensor, then you are going to go and override this particular set of method, right? So you have a possibility of all the extensions that you can do with all the entities, right? So maybe you wanted to add some custom behavior to the sensor, maybe you are trying to do it for a camera specifically, for a temperature reading specifically, or certain kind of thing, then you can extend the sensor for that. So this send tuple, what it is going to do is it is going to set the VM ID, it is going to set the device ID, it is going to set the destination, and then it is going to send the tuple correspondingly to the tuple arrival, right? So this is the method which is going to be called, but right now this send tuple is not being used. If you can see here, these particular set of instruction, this instruction at 169 is being marked commented, right? So right now the get device is going to do all this work for you. So you can say that this particular is temporarily deprecated method, right? So it has not been used, but yes, it is there, and will be specifically used whenever it is required to be. Then comes is a shutdown entity, right? So shutdown entity is basically a method which is going to be there because the sensor is extending the sim entity class. So start entity and the shutdown entity, both methods are going to be there. So shutdown entity is empty right now. If you are trying to do any kind of specific job or any kind of specific printing that should be done at the time of exit of the simulation, you can do that. Otherwise, the start entity is going to be called whenever the simulation is going to happen, and you can see what exactly it is calling. It is sending a method with the transmission distribution next value, and what tag it is sending emit underscore tuple, right? So that means whenever the sensor is going to start, it is going to go for this particular event so that the particular tuple can be generated and sent to the level above it, right? So that is the start entity and shutdown entity. And apart from this, the other method which is there is the update timing method, which is a private method here, and we have already discussed about it, that it is going to look at the application, then loop, and then it is going to do a tuple generation, a unique tuple ID generation, that is through the timekeeper, because it is based on the instance, and then it is going to get the unique ID corresponding to that particular instance. So this is what we get in terms of the sensor based class, right? So overall the objective is to perform a kind of modeled behavior inside the iFogsim simulation, where the sense of real world sensors can be generated during the simulation time. So that is the primary purpose of this particular sensor class.